Okay, let's take a look at your worksheet 5.62. On all of these problems, you are asked to solve for x involving some sort of logarithm, whether it's natural log or the common log. At least these first ones here are all going to pretty much deal with natural log. So we're going to be dealing with natural log and e. So on the first one, I want to actually be pulling up my calculator here because it just says e to the fifth equals x. So this is just simply finding e on our calculator, which is second ln. You'll get the e to the power. We'll put a 5 there, hit enter. So all my answers I am going to round to 3 decimal places. So x equals 148.413. So that takes care of number 1. On number 2, we've got a little more algebra to do, and we have to solve for x in the exponent. So we have an e to the x. It's going to involve a natural logarithm here. So on number 2, first thing I'm going to do is subtract 25 from both sides. I'll show all my math here, or at least try to here. So I have 3e to the x equals now 540. So now if I divide both sides by 3, I get e to the x equals 180. So now I'm going to change this, since it's in exponential form, to log form. Remember how this works. It's something you need to know, love, make your best friend. So we use log. The base is the number e to the number 180 equals x. Remember how logarithms isolate the exponent value. That's what we want. Log base e, another term for it is natural log. So natural log of 180 is equal to x. If you want to go from e to the x to right to natural log of 180, more power to you. It will actually save you a step each and every time. So natural log 180, enter it in my calculator, and I get 5.193. So x equals 5.193. On the next one, what's nice about number 3 is, notice how x is already all by itself. So this is one where you're plugging in all the values right into your calculator. We're just going 200 and then e, so second natural log, to the 0.04 times 7 power. Well, I don't have to end my parenthesis there, sorry. But on some calculators, you'll have to put that top part in parentheses. So hit enter, 264.626. So x equals x equals 264.626. All right, number 4, I'm gonna move these up a little bit, switch colors. So I have 5e to the 3t power. So again, rewrite it in log base form. So log base e of the number 5 equals 3t. Now some of you might have been able to go, all right, well, this is just going to simply be natural log of 5 equals 3t. So to get t by itself, I divide both sides by 3. So I'm just taking natural log of 5 and dividing it by 3. So calculator, natural log of 5 divided by 3. Make sure you close that parentheses on that 5. So we get t to be 0.536. Number 5 just has a few more algebra steps. So the first thing I want to do is divide both sides by 250. So 250 goes into 1500 6 times. So now I have 6 equals e to the 0.06t power. So if you write this in log form, log base e of 6 equals 0.06t. Isolates the exponent. Log base e again is natural log. So natural log of 6 equals 0.06t. So I'm going to divide both sides by 0.06, divide here by 0.06, kind of squeeze in there. But, so on my calculator, natural log of 6 divided by 0.06. And I get 29.863. So t equals 29.863. All right, on the next one. Here I have the natural log of x equals 2. So if it helps you, rewrite it using the base e form so that you can see that it's still in log form. I don't have x by itself, so I'm going to rewrite it in exponential form. Base is e to the number, or I'm sorry, to the exponent, which is 2, equals the number. So now x is by itself, we just have to take e to the second power. So on my calculator, second natural log raised to the second. I apologize that I keep on doing that, putting that parentheses. I'm used to the older calculator. So 7.389. 7.389. Moving right along to number 7. Number 7, we want to first divide both sides by 30. So now it's just natural log of x equals 0.4. So just like the last one, log base e of x equals 0.4. Now I rewrite it in exponential form. E to the 0.4 power equals x. So calculator time, second natural log, e to the 0.4, enter, x equals 1.492. All right, on number 8, we need to, again, isolate the x the best we can. So I'm going to add 2 to both sides. So I have 5 natural log of x equals 15. Divide both sides by 5. So natural log of x equals 3. So if I think about this like log base e, which is the same as natural log, then I can rewrite this as in exponential form. E to the third power equals x. So, calculator time, e, second natural log, so I get the e to the third power, 20.086. So x equals 20.086. All right, on the last one here, if you take a look here, the x is right here. The question is, can I simplify this piece? I actually can by just simply typing that in my calculator. 5 natural log of 20, that's just a number. So 5 natural log of 20, I'll close the parentheses on that. So I get 14.979. 14.979. Now it's just like a basic algebra equation. Add 1. So 4x equals 15.979. Divide both sides by 4. So x ends up equaling 3.995. All right, so that takes care of just kind of the basic natural log type problems and base E type problems algebraically. Now how we can put some of those equations and use them in some sort of context. So if we look at number 10, it says an amount of $3,500 is deposited in a bank paying annual interest rate of 2.5% compounded continuously. That tells you you're using the PERT formula. How much money will you have after 7 years? So in part A, it just asks you to set up the exponential equation that can be used to answer this question. So we want to know the end amount y. The initial amount is our P, which we are told is 3,500. Then we have E, since it's continuously, and then we have to figure out what the rate is in the year. Our rate is 2.5%. Move that decimal over 2 spots, so 0.025, and our time was 7 years. So then, all we need to do is, for part B, says solve your equation showing all of your work. Okay, so y equals, so we just have to plug it in. This one really doesn't take anything that we have to show other than the setup of it, so 0.025 times 7, so plugging it into my calculator, and I end up getting $4,169.36. $4,169.36. So that one actually didn't take any algebra to solve because all the numbers were on one side. Very nice. However, on the second one, you'll see you're actually going to have to do some algebraic work. So here it says on 11, Mr. Bartz puts $5,000 in the bank. Nice. The bank offers an annual interest rate of 8% and compounds interest continually. How long will Mr. Bartz need to leave his money in the bank until his money triples in values? So when we're talking triples, it needs to be 3 times the amount. So when I set up the equation here in part A that can be used to answer this question, my y value is 3 times my starting value. So 3 times 5,000 is 15,000. That has to equal the initial 5,000 times e to my interest rate, which was 8%, so 0.08 times t, because how long, that's what we're trying to find, is the t value. So now all of a sudden, if you look at this equation right here, if you scroll back up to the top, they kind of start to look like a question like number 5. Okay? So you just have to solve it in a similar fashion, just different numbers, but same process. So that's what you're doing in part B. So in part B, I'm actually just going to show it right here. I'm going to divide both sides first by 5,000. So I really get just 3 equals e to the 0.08 t power. Now if it helps you, write it in log form. Log base e of the number, so of 3, is equal to the exponent. Log base e is the same thing as natural log. So natural log of 3 equals 0.08t. Now we're going to divide both sides by 0.08, and I'll get my t value. Plug that in. Natural log of 3, close parentheses, divided by 0.08, equals 13.733 years. Let's just go to the nearest tenth for the year. So 13.7 years. Okay, so it's going to take a little time, but hey, that's tripling in value. All right, so this ends the first page.